Okay, so what is nCr or nCr and why do we need it? That is the point of our video. So so I actually have it written as nChoose k times p raised to the k times 1 minus p raised to the n minus k. This was the formula we saw yesterday in our binomial distribution notes. That's whenever you have a binomial setting where you can check the bins. If you guys remember that, B is for binary, where there are two options essentially. Something is either a success or a fail. It happens or it doesn't. Okay, so it's binary. There's only two options. The I is for independent, meaning each individual trial is independent of the last one or the next one. N is for a set number of trials, and then S is for the same probability of success for each trial, okay? So the example that we looked at in class the other day was the 3 free throw situation where an individual at the end of a basketball game had to shoot 3 free throws, and we wanted to know what was the probability of him making all of his shots, okay? And if we wanted to, we could, so we'll say let x equal number of free throws made, okay? And then we'll say that his probability of success was 0.72. We'll keep it the same, okay? So I could create my probability distribution here. The different options here, if he's shooting three shots, there are actually 4 options for him as a result. He could miss all of his shots, he could make 1, he could make 2, or he could make all 3, okay? And so then we can find the probability of each one. Now, the probability of 0 and the probability of 3 are the easiest to find because the probability that he makes all 3, well, the probability that he makes the first one is 0.72 times the probability that he makes the second one and the third one, so 0.72 cubed, and that's going to be 0.373, okay? It's very similar to do the probability that he makes, or I'm sorry, that he misses all of them. That's going to be 0.28 again to the third. So that's going to be 0.022, okay? Now, for each one of these, there's only one way to make all 3 or to miss all 3. You either make them all or you miss them all, okay? But when it comes down to making 1 or 2 shots, there are actually multiple ways of this happening. You could make the first one, but miss the next 2. You could make only the second one, or you could make only the last one, okay? Likewise, if you wanted to make only 2 shots, you could make the first 2, miss the last one, make 1, miss 1, make 1, or you could miss the first one and make the last 2, okay? So each one of these, though, has its own probability of occurring. So the probability that you make 1 but miss the last 2, okay, that should be a squared, not a 3, okay, squared. That's a probability of this guy happening. But we have to, factor in all 3 combinations. So that's why we multiply by 3 here, because there are 3 ways for this to happen. Same thing over here. There are 3 ways for them to make only 2 shots. They can make the first 2, so 0.72 squared times 0.28, okay? So this number right here is where this guy comes into play, okay? So in choose K, this means the number of trials total compared to the number of successes. And essentially what this helps us do is determine the total combinations possible for N trials and K successes. Okay, what does that mean? Okay, so for example, this number right here, this 3, okay, if I were to shoot the ball 3 times, I want to know what's the probability of having only 1 success. Well, as we can see here, there are 3 ways to do that. Here's the first way, second way, third way, okay? So if I type this in my calculator, 3 choose 1, that's going to be a 3. Again, this only tells me the total number of combinations. And the combinations is important because I have to multiply the number of combinations by the probability of each combination occurring, okay? Same thing over here with 2 shots, okay? So I'm going to shoot 3 shots. How many ways are there to make 2 of them? Well, again, we've already done the math here, like I was doing it the long way. There are 3 possibilities, okay? And when there's only 3 possibilities, like that's honestly really easy to do by hand. This nCr or nCr formula comes in really handy for situations where I'm like, okay, well, what if the guy shot 20 shots? What's the problem? Like, how many ways could he make 4 shots? Okay, so you could write all of those different combinations out, but I don't want to write all those out. So the nice thing is we can just do this formula to where nCr, where we don't even have to like work all that out, okay? So let's say, for example, that I wanted to know if I have a shooter that shoots a 72% shooting percentage, so 0.72 equals probability of a make. Let's say they shoot 20 free throws. Okay, I want to know what's the probability of 4 makes out of 20. Okay, so I know to find the probability of just one of those ways, the probability of success is 0.72, and they're going to have to make 4 of them, but that means they missed 16 of them, okay? But I know that this can happen a lot of different ways. I don't know how many different ways, okay? But I know that it can happen a lot of them. To calculate that, I'm going to use 20 choose 4, okay? And I'm just going to use my calculator to find that, okay? To get this in your calculator, you're going to click Math, arrow over to Probability, and then you're going to arrow down to, I believe this is option number 3, and it'll say nCr in your calculator, but that's the same thing, okay? You could also do this from the home screen. You click Alpha, and then F2, which is actually the window button, and then it's going to be number 8 is nCr, okay? But basically, in order for you to find the total number of combinations, you have to make sure that you do this in conjunction with finding the probability, okay? So this right here, this overall formula would give me the probability that they make 4 out of 20 free throws if he was a 72% shooter, okay? I hope this helps clear that up as to what nCr means. For all of my really, really mathy kiddos out there, you might actually see this another way, and sometimes I'll write instead of 20 choose 4, this is the same thing as 20 choose 4 written that way, okay? It's like a big parentheses, but then it looks like a fraction, but not quite, okay? The formula for this, if I have it in over k like this, that's going to be n factorial over k factorial times n minus k parentheses and then factorial. This right here, guys, if that confuses you, please ignore that, okay? This right here is for my folks who have seen the factorial in pre-cal. Some of us have, some of us have not, okay? If you've seen that, great. If not, don't worry about it. Just know that sometimes I will intermittently change between this format and this format, but they mean the exact same thing. 20 choose K or N choose K, the number of trials. I want to know how many successes out of so many trials, like all the different combinations. That's what N choose K represents. So if you have questions, let me know, and